Hello everyone! It's another learning day. We are going to continue the discussion on the world of quadrilateral. Again, this is your teacher Marlene, and we have to focus our discussion on the trapezoid. Can you identify the trapezoid among the figures on the board? Yes, it is the trapezoid. So let us take away the parallelogram, the rhombus, and the rectangle. The trapezoid is also known as trapezium, and it is described as quadrilateral with one pair of parallel sides. So in the figure of trapezoid LOVE, LO is parallel to EV. Let us show the parallel symbols in the figure. So LO and EV are parallel. Now, let us look at the parts of trapezoid. First, the pair of parallel sides of trapezoid are called the bases. So the bases are LO, which is one of the base, and EV, which is the second base. The second part of trapezoid are the non-parallel sides, which are called the legs of trapezoid. So the legs are LE, one of the legs, and OV, which is the other leg. Now, the other part of the trapezoid is the median. The median of the trapezoid is the line segment joining the midpoints of the non-parallel sides. So looking at the leg LE, let us get the midpoint and label it as point Y. Similarly, in leg OV, let us get the midpoint and let us name this as point U. Now connecting the midpoints will show us the median, and the name of our median is YU. Now the median has a special property to find the lengths of the bases or median itself. There is a theorem which states that the median of a trapezoid is 1/2 the lengths of the bases. So, the median can be found using the formula YU is equal to 1/2 times the sum of the bases, which are the LO and EV. Now let us name the theorem I have mentioned before, and this is the Midsegment Theorem of trapezoid, which states that the median of trapezoid is parallel to each base and its length is 1/2 the sum of the lengths of the bases. Now let us prove this Midsegment Theorem of trapezoid. Let us choose this illustration. So our given is trapezoid LOVE with median YU that intersects the diagonal LV at T. Then we have to prove that EV is parallel to YU and is also parallel to LO, and YU is equal to 1/2 times the sum of LO and EV. Let us start proving by writing our statements and the corresponding reasons behind. So it's stated in our given that the trapezoid LOVE has median YU that intersects the diagonal LV at T. So using the segment for median, YT plus TU is equal to YU. And this is about the segment addition postulate. Now looking at the diagonal LV in our figure, our trapezoid is divided into two triangles such that we can apply the last lesson about the midline theorem in the triangle LEV. We can say that YT is parallel to EV and YT is equal to 1/2 of EV. The same with the inverted triangle LOV, that TU is parallel to LO and TU is equal to 1/2 the length of LO. Now, EV, which is one of the bases of the trapezoid, is parallel to LO, which is the other base, and that is by definition of the trapezoid. Then EV is parallel to YT plus TU and is parallel to LO. That is by transitive property using the statements 3 and 4. So YT plus TU is equal to YU. Therefore, EV is parallel to YU and is parallel to LO, that is by addition property. So YU is 1/2 LO plus 1/2 EV. That is by substitution property. Then since 1/2 is present on the equation, we can factor it out. Therefore, YU is equal to 1/2 the length of LO plus the length of EV. Now, a special kind of trapezoid is the isosceles trapezoid. Let us have this figure of isosceles trapezoid HOPE. It is isosceles if the legs are congruent. So, HE is congruent to OP in symbols to signify that they are congruent. Now, what are the special features or properties of isosceles trapezoid? First, the base angles are congruent. Since we have the upper base and the lower base, then angle E is congruent to angle P, which is one of our lower base angles, and also angle H is congruent to angle O, which is the upper base angles. Another property of isosceles trapezoid is that the opposite angles are supplementary. Therefore, the measure of angle H plus the measure of angle P is equal to 180 degrees, in which angle H and angle P are opposite angles. The same with the measure of angle O plus the measure of angle E is also equal to 180 degrees. Since the two sides are congruent, their diagonals are congruent. So the diagonal HP is congruent to diagonal OE. Let us prove this idea about the isosceles trapezoid. So using the figure, the given is isosceles trapezoid AMOR with MO is parallel to AR. We have to prove that angle A is congruent to angle R and angle AMO is congruent to angle O. Let us have the columns for the statements and the reasons. So it is stated that the isosceles trapezoid AMOR with MO is parallel to AR, which are the parallel sides of the trapezoid, and this is our given. Segment AM is congruent to segment OR. This is by definition of isosceles trapezoid. Then from M, draw ME such that ME is parallel to OR and E lies on AR. This is using the postulate that the 2 points determine a line. Then, the quadrilateral MORE is a parallelogram because the opposite sides of parallelogram are parallel, which is the definition of parallelogram. Then segment ME is congruent to segment OR because any two opposite sides of the parallelogram are congruent. We have segment MA is congruent to segment ME. This is by transitive property. We can use our statements numbers 2 and 5. Then the triangle AME is an isosceles triangle using the definition of isosceles triangles that the two sides of triangles are congruent. So angle A is congruent to angle 1 by base angles of an isosceles triangles are congruent, where angle 1 is also congruent to angle R using the corresponding angles theorem. Now angle A is congruent to angle R by transitive property using statements 8 and 9. Then we can say that angle A and angle AMO are supplementary angles. Same with angle O and angle R, they are supplementary angles because it is the same side interior angle theorem. Therefore, angle AMO is congruent to angle O because supplements of congruent angles are also congruent. Now we are done in proving our theorems. Let us look for its application. So we have GLAD is a trapezoid with side GL that is parallel to side DA. And then we have if the length of GT is equal to 8 and the length of LA is equal to 20, find PD, GD, LY, and YA. So to answer this, we are going to use the idea that P and Y are midpoints of GD and LA. So in the case, it divides the segments into two congruent parts. Therefore, if we have GT is equal to 8, then TD is also equal to 8. And since GD is the sum of the segments GT and TD, by substitution, GT is equal to 8 and TD is also equal to 8. So 8 plus 8 is equal to 16. For LY, which is half the measure of the length LA, therefore 1/2 of 20 is 10. And since LY is equal to YA, then YA is also equal to 10. Another application is using the same figure, and we have to answer if the length of GL is equal to 18 and our DA is equal to 22, then what is TY? So TY is the median. By substitution, we have TY is equal to GL plus DA, which are the lengths of the bases. So we have TY is equal to 1/2 the length of GL, which is 18, and the length of DA, which is 22. So 18 plus 22 is 40, and 1/2 of 40 is 20. So this is the length of TY. Okay, we are done with all the concepts pertaining to the trapezoid. And how well do you know about this question? Which of the following is not a trapezoid? Is it our G? Is it the figure L? Or is it figure A? Or figure D? So put your answer in the chat box. Thank you for watching. God bless everyone.